So far in our functions unit, especially the last two classes, we have looked at functions as a situation and as a graph, right? Situations and graphs, and we're matching them. Today we're going to start looking at equations, functions as equations, okay? And so we're going to use this notes template, and I'll probably go rogue for a question or two as well, just because I want you to see some other stuff. So, functions, we've already seen graphs, we've already seen stories, but they can also be an equation, all right? What's cool about equations is when there's two variables, like we're going to see today, they're infinite answers. And when there's infinite answers in math, we have to have some other ways to show it, right? Because it can't just be like x equals 4. That's only one answer. These will generate ordered pairs by taking an input that results in a certain output. So that's kind of like down here. We saw that on a Decimos earlier where there was, I think we called it a function machine. And we said, hey, this number's going in. What has to be happening to this number? We have inputs and outputs. They're going to come out as an ordered pair. Remember, an ordered pair is an XY value that corresponds to a place on a graph. Okay? The graphs that we're going to be looking at in algebra primarily, they're either going to be straight lines or curves. So don't write this in, but we'll look at linear. We'll look at absolute value probably. We'll look at exponential. And we'll look at quadratic. All these are straight lines or curves, okay? You don't need to worry about what those are specifically. Today we're going to focus most on lines, but we'll see some other stuff because the principles that we're going to use to graph these and use the equations, it holds true for all functions. So just for some language to get on the same page, x value sometimes is called the independent variable because we get to pick it, and the x value determines what the y value or what gets pumped out would be. So the y value is dependent. And if you want some help remembering that, right, like, and you know that from science even, right? Your x value is your independent value, and your y value is your dependent value every time you graph something with your scientific data in science class, and every time you've done it in math. So I know there's lots of words for x and y, right? We have x, y, we have independent, we have domain and range, we have input, output. All those are meaning the same thing, right? Just like in the English language, there are multiple words that mean the same thing. Sometimes that happens in math too, and I want to make sure we're all able to use that language. Cool. So that's all the languagey stuff we need to take care of. Let's look at some numbers. What we're going to do here is you're given a function or an equation, okay? You're given a domain. We're going to use that domain to pump out a range. Now, we can pick anything in here. These ones are self-selected for notes. You can pick any domain you want. My favorite domain choice, which is not on any of these, is -2, -1, 0, 1, 2. That's my favorite domain choice because I get small numbers that are both positive and negative, so I can kind of see how things are working. That's my favorite domain choice. However, I would not use that domain choice for number 2, and you'll see why when we get to number 2. Anyway, for this notes template, though, we're given domain -5, -4, -2, 0. These are my independent variable. They're going to be my input into the function, and then my function's going to pump out a y value, resulting in an ordered pair. So I'm going to take my x values, and I'm going to substitute them into my function, just like our warm-up. That's why that was our warm-up. On some of these, I show more work than others. On this one, I'm going to show more work than I normally would, just so you can see what we're doing and why. So when x is negative, really what I'm asking is, when x is -5, what is y? Well, y is equal to x, which in this case is -5, plus 4. So -5 plus 4 is -1, which tells me when x is -5, y is -1. And that is that spot on the graph. When x is -5, y is -1, that's that specific location on the graph. So I'm going to substitute in one more. So now, remember, x can be like anything. So the next domain we're going to use is -4 for x. So when x is -4, y would equal 0. And that's for this specific function, y equals x plus 4. Okay, so when x is negative 2, we're going to throw a negative 2 up there. Y would equal 2. So when x is, I did something wrong. What did I do wrong? Negative 4 plus 4 is 0. Oh, I got my second point wrong. Why don't you guys tell me that? Negative 5, I got my first point wrong. Oh, let me get back here. Alright. Negative 5, negative 1. Negative 4, 0. Okay, we're back in business. Negative 2 would pump out a 2. Should be right there. And 0 would pump out a 4. Which would be right there. Now, this is saying graph the function. The function isn't this specific domain and range only. These are just reference points. The function is the whole equation. This equation has infinite answers. So the whole thing would be a continuous situation. That line right there. All right? So what's cool is we can graph equations now. We can always get it. And you can always graph any equation by substitution. It's an option. Now later, I'm going to show you easier ways to graph these. But for right now, the equation is where it's at. We're going to jump down to number 4. Who can tell me what they notice is different about number 4 than number 1? Raise your hand. Lyndon?
Well, with number 4, it has a fraction, and it also has a minus at the end.
Yeah, so we have a fraction. And number 4, negative fraction, right? Coefficient is another word we use for that value. So things are going to look different there. And then you did notice it's negative. Now, check out the domain. This domain specifically has even numbers. Anybody have an idea why? If I would choose a domain, this might be a domain I choose. I would not use negative 2, negative 1, 0, 1, 2. What's up with the evens? Why are those chosen? Any ideas? Who can raise your hand and tell me why they think we have even numbers for the domain? Because there's a reason. Looking for some hands. Was that you, Tanyan? Who was that? Yeah, Tanyan. Why are you thinking?
It's easier to use with fractions.
In this fraction specifically because the denominator is 2. So I can cross simplify if I'm using even numbers, right? So like if your denominator was a 3, I would use multiples of 3 just to get rid of the denominator. So let's start plugging in our x values. So when x is negative 2, y equals negative 3 halves times negative 2 plus 2. The reason why this one's nice is these 2's cross simplify. I'm left with a negative 1 up there. And my math's just easier now. Negative 3 times negative 1 is 3 plus 2 is 5. So when x is negative 2, y is 5. Let's plug in a 0. 0 is the nice one. Because check this out. This whole term, when I multiply by 0, turns into what? 0. So I just have to do 0 plus 2 there to get 2. That's a special point called the y-intercept. We'll talk more about that later. All right, let's substitute in a 2. I'll write that one in. Negative 3 halves times 2 plus 2. My 2's are going to cross simplify, leave me with a 1. Negative 3 times 1 is negative 3. Plus 2 is negative 1. So when x is 2, y is negative 1. We got one more. We got a 4 to mess with. So when x is 4, and notice I like writing it as 4 over 1. It just helps me with my multiplying my fractions. My 2 and my 4 cross simplify to make a 1 and a 2. That gives me a negative 6 plus 2 for negative 4. We all good where I got those values? Okay, some of us are still working on that fraction work I noticed on that last quiz, but you know, this fraction work's important. They're not going away ever. Next thing I'm going to do is I'm going to graph my ordered pairs that come from my domain and range there. So I got negative 2, 1, 2, 3, 4, 5, negative 2, 5, 0, 2, 2, negative 1, and 4, negative 4. Again, we have a line. Pretty much anytime we have an x to the first power like this, we're going to have a straight line. Infinite number of domains and range on that line. These are just reference points. So for number 4 there, these are just reference points. We could pick other stuff. I probably would have picked, if I made it, I probably would have done negative 4, negative 2, 0, 2, and 4. I would have done the next one. I like just seeing positives and negatives, but cool. All right, so here's what you're going to do. You're going to try number 2 and 3 on your own right now. So I'm going to give you a couple minutes. Try 2 and 3 on your own, please. On number 3, y is always equal to 3 times x. So our x values, our domains going in, pumping out a y value. Okay? So 3 times negative 2, negative 6. 3 times negative 1, negative 3. 3 times 0, 0. 3 times 1, 3. Thumbs up if we're all good there. Okay, then we're just going to graph it. Negative 2, negative 6. Negative 1, negative 3. 0, 0. And 1, 3. And because this function has infinite answers, it's a continuous line. There it is. This next one, guys, people let those fractions get in their head, but fractions no big deal. All right? I'll show these ones substituted in, though, just so we can keep practicing. So I got 3/4 times negative 4 minus 2. Those cross simplify. Negative 3 minus 2 is negative 5. I've got a 3/4. Oh, I'm not going to do the 0. I'm going to do the 0, but I don't need to substitute it in, right? Because times 0 is just 0. Minus 2 is negative 2. All right, so next I have a 3/4 times 4. 4 and 4 cross simplify. 3 minus 2, 1. And the 8. 4 and 8 cross simplify to make 2. 3 times 2 is 6, minus 2 is 4. So here's my ordered pairs. That 8, 4 is not going to fit on there, but that's okay. Here's negative 4, negative 5. 0, negative 2. And 4, 1. There's my continuous line. That is a representation. So, like, again, yesterday, the day before, we had stories and graphs. Now we have graphs, tables, equations, multiple representations of the same things. All right, I'm going to go rogue. This one's not on your template. Okay, I'm going to go rogue on one for you. Let's say we had something like y equals the absolute value of x minus 2. All right, I get to pick my domain and range. I'm going to choose domain negative 2, negative 1, 0, 1, 2. I like having positives and negatives, and I like having values that are small. So you can choose any domain, right? This function has infinite answers. So I'm going to put in my domain, pump out my range. So when I put negative 2 in for x, the absolute value of negative 2 is 2. 2 minus 2 is 0. Substitute negative 1 in for x. Absolute value of negative 1 is 1. 1 minus 2 is negative 1. Substitute in 0 for x. Absolute value of 0 is 0. Minus 2 is negative 2. Substitute in 1. Absolute value of 1 is 1 minus 2. Negative 1. Substitute in 2. The absolute value of 2 is 2. Minus 2 is 0. Here are my ordered pairs. I'm going to graph these. I've got a negative 2, 0. A negative 1, negative 1. A 0, negative 2. A 1, negative 1. And a 2, 0. These absolute values, you'll notice, they're always going to make a V. Like that. So again, it's not a line, but it's the same exact process. We're going to pick a domain. We're going to substitute our domain into our function. It's going to pump out a range, which with the information combined is going to give us our XY ordered pairs that we can then graph to give us a visual representation of the function. Okay? So a lot of times I'll ask you to graph these. You'll just be able to pick your own domain and range. This is my fave. Negative 2, negative 1, 0, 1, 2. Unless there's a fraction, then I'm looking to get rid of my denominator. All right, there's one other type of problem on this template. I think I only want to do like one of them. Let's do number 10 from your template. Okay, and I'm just going to write it out. Number 10 from your template is y equals 3/5 x plus 2. They're giving you a domain of negative 10, 0, and 5. All it's asking for is what is the range. So I'm going to be looking for a range here. To get my range, I like to mess with an XY table. Okay? I'm going to take my domain, put it into my function, pump out an ordered pair. So when I pump in a negative 10, I like to write it as a negative 10 over 1. These cross simplify. That's why negative 10 is a good choice for a domain here. 5 would become 1. Negative 10 would become negative 2. And I've got a negative 6 plus 2 for a negative 4 there. I plug in a 0 here. That whole part becomes 0. So my output would be 2. And if I plug in a 5, I've got an opportunity to cross simplify again. Those become 1s. 3 plus 2 is 5. So my range would be negative 4, 2, 5. That's the answer something like negative 10 on, or number 10 on your template would be looking for. And guys, that's everything we need to know. Let's go big picture. Let's go big picture. We have input and output. That's X and Y. Sometimes you'll see the Y as an f of X. These are interchangeable. Okay? So input, output. Input is our independent variable. The output is our dependent variable, because it depends on what goes in to our function, right? This is also going to be our domain and range. And when we get all these things together, they're going to give us ordered pairs, which we then could put on a coordinate plane for another representation, right? So we've done stories that match graphs. Now we have equations. Now we have tables. Now we have functions, right? All different ways to represent similar things, right? Because if math is communication, we need different ways to represent multiple things. So I'm gonna stop the notes here and show you the homework for tonight. I'm gonna let you get cracking, all right?